1.
All right. Here we go. Quadratic functions. We'll start with the standard form of a quadratic. And that's that form that we talked about yesterday where you got f of x equals ax squared plus bx plus c. All right, so standard form. A, b, and c are just numbers. Normally, they're going to be integers for us most of the time. Sometimes they might be fractions. Not very often, but most of what we work with in the quadratic world, those are integers, whole numbers, that sort of thing. So nothing major about that. All right, so when we think about that standard form, how do we know which way that opens? You know, it's a parabola, so it's going to be this shape, or it could open down like that. That's sort of thing. Okay, so how do we know if it opens up or down? The number in front of x squared. Yeah, that a value, positive or negative, decides that. Okay, so if a is greater than 0, it's going to open up. And if it opens up, then it's going to have a minimum, an absolute minimum. We'll talk about those in chapter 3. And if a is less than 0, meaning it's negative, it's going to open down, and it'll have a maximum. Absolute maximum. Okay. All right. Well, and that absolute maximum or absolute minimum is going to occur. What's that point called? That point, like right here or right up here. The vertex. Yeah, that's what it's called. So, vertex. That's our absolute max for. While we're talking about it, it's a function. So one of the things we talk about with every type of function we've done anything with is domain and range. So the domain negative infinity to positive infinity every time. Your range for that is dependent on A and the y value of the vertex. So if it opens upward, you're going to have a range that starts at the y value of the vertex and goes to positive infinity. If it opens down, you're going to have a range that starts at negative infinity and goes to the y value of the vertex. So your range is going to change. Your domain, though, is always that. Okay. All right.
Good morning, AJ. Please rise for a pledge of allegiance. I pledge allegiance.
Okay, so with the standard form and with any parabola, that shape, right? And it's got an axis of symmetry. These are the important things that we're going to find today. We're going to do vertex form or standard form. We'll do an example. We'll do vertex form. We'll do an example. We'll do factored form. We'll do an example. It's kind of how I'm trying to go about this. But we've got to get all these formulas and things first for this form. The axis of symmetry is an equation. I feel like you've seen that before. Negative b divided by 2a. You're getting b and a from the equation. Okay, and it's always x equals negative b over 2a for a quadratic function. All right, and what it does is it creates that line. See these two holes in the shape here? It's a kind of an imaginary line that if you could fold this it would match up symmetry, line of symmetry. We've talked about that previously in here. Okay, so that's your equation for axis of symmetry, and that also gets you the x value for that vertex. To get the y value for a vertex, if you've got an x value, to get a y value, what do? If you got an equation, just plug it in. Find the f of negative b over 2a. So you plug it in, get the y value goes with it. So we're going to have to talk about range, we would have to find the vertex anyway. So that's one of the reasons it's important for that. And then intercepts are also important. So what kind of intercepts could we have? X and Y. So y-intercepts, the y.
Make that your list report to the office.
If it's in standard form, it's just whatever C is. Technically, it's plugging in 0 for X, but it turns out to be C every time if it's in standard form. Okay. And then your X-intercepts, a little bit more difficult. That's related to that problem we did at the beginning of the class, where we had to find the solutions for that quadratic. It was in standard form. You got options. Your first option would be factor. Technically, we set it equal to 0 first for any of these options. Set it equal to 0 and 1. You can factor it. Greatest common factor, then X method. It's usually a trinomial, that sort of thing. Or you can use quadratic formula. Remember, x equals negative b plus or minus b squared minus 4ac divided by 2a. So that's your quadratic formula. You could use that. A, b, and c still come from the standard form. Now, one of the things I want to bring out here in this thing is, what's that part right there? You may remember the name of that. Well, it's under the square root, but it's got a special name. Starts with a D, ends with a discriminant. Okay, so it's the discriminant. All right, and what it does with the quadratic formula is it tells you whether you even have x-intercepts or not, and how many or what kind. All right, so let's get that information here. Your discriminant. That's the b squared minus 4ac. All right. If that works out, you work that number out that you get there. If it is less than 0, that's going to create a complex number because it's going to take a square root of a negative number, right? Remember, that's where the I comes from. So that's complex, and that means there's no x-intercepts. It's got complex solutions, then there's no x-intercepts. It's not going to cross the x-axis, period. You can look at the graph and tell that too. All right. If b squared minus 4ac is equal to 0, it's going to have one x-intercept. That one x-intercept will be at the vertex. That's always going to be the case. And then if you work out b squared minus 4ac, and the other option is it's greater than 0, you'll have two x-intercepts. So if you get a positive number there, you'll have two of them. And if it's a perfect square, then it's going to be nice. It would have factored, like is what it means. It means that the quadratic would have been able to be factored. But if it turns out to be like the square root of 7 underneath there, then we know it's going to be decimal forms of stuff there is where we're going find the x-intercepts. All right. All right. So those are the important things that we're going to be finding today. So axis of symmetry, our vertex, our intercepts y and x, and the graph of it. Kind of like what's the graph look like? Where can we go from there? So those are some of the important things we're going to find today. So let's look at an example of one in standard form, and we'll do a fairly simple one and get all of that information out of there. So here's our function. F of x is equal to x squared plus 7x plus 12. Real easy one here. And in Algebra 1, I always made you make the list of A, B, and C. I remember doing that. If you had A for Algebra 1, if you didn't have A, I don't know if you did that or not. What's A? 1. It's the number in front of x squared. B is 7, and C is 12. All right, so we're going to go through that list and find those things that we need to know. We need to know the axis of symmetry. And you can abbreviate that if you want to. I'm just writing it all out in the notes here. So it's x equals negative b. So negative b would be negative 7 over 2 times a. Yeah, so 2, yeah. So negative 7 over 2. So the axis of symmetry is x equals negative 7 over 2 or 3.5, whichever, 3.5. We go to graph that. That's what we're going to think. That's 3.5. Negative 3.5. Okay? Now, from there, we go to the vertex. Because the vertex, we get the x value for the vertex for free. Because that's the same thing as the axis of symmetry. Your vertex will always be intersected by your axis of symmetry every single time. If it does not, something went wrong in your graph. Okay? So how are we going to get the y value? It goes with it. Plug it in. So f of negative 7 over 2 is what we're working out. And I'm fine with using the calculator to do that. Doesn't matter to me. I may not have. I will. I will just say, okay. Thank you. I did not. I went there to do it and didn't do it. Let's pause that. So not everybody. Come on. Quadratic again. All right. Plugging that in. Again, I'm fine with it. Using the calculator to do this. I'm not going to. 49 over 4 minus 49 over 2 plus 48 over 4. I'm just changing that to, so that's 98 over 4. Be negative 1/4. All right. If you did that with the calculator, did you get negative 0.25? Here's how I would do it with the calculator. I'd go to y equals, and I'd type in my problem. I'd go to y equals. I'd clear out all this other junk. And then type in x squared plus 7x plus 12. And then I'd go to my table, so second graph, and I'd type in negative 7 over 2. Negative 0.25. And then you think about that as a fraction. So, and again, go to y equals, type in your equation that you have, and then second graph takes you to that table, and I've got my table set up to where I type in what x values I want. So I typed in negative 7 over 2, which we said was negative 3.5. It converted it, and then that gives me the y value up back. And I'm just thinking, oh, I know that's negative 1/4, so I'm writing it as a fraction. Okay. All right. So there's my vertex. From there, we need to talk about our intercepts. That's important, and then we'll talk about domain and range. What's the y-intercept? 0, 12, right? That's one of our intercepts, 0, 12. So if you plug in a 0 for x, you're going to get 12 back. Okay. The other intercepts could be found by setting x squared plus 7x plus 12 equal to 0. And I'm going to try to factor that because I'm quicker at factoring than I am quadratic formula. So I multiply to be 12 and add to be 7. 4 and 3, so that's x plus 4, x plus 3. So x equals negative 4, x equals negative 3. So my intercepts there are at negative 4, 0, and negative 3, 0. So I've got 2 x-intercepts and a y-intercept there listed. You won't always have 2 x-intercepts. Sometimes you'll have one, sometimes you'll have none. Okay, so keep that in mind that that's going to happen. And if it won't factor, like if you don't get the factoring on the first try, man, I'd jump to quadratic formula and just do it. Okay, because that's what you're going to need to do probably. And then the next thing we need is what? Did our intercepts, we did all our axis of symmetry and our vertex. So let's talk about the domain. What's the domain? Yeah, all real numbers, negative infinity to positive infinity. The range. Okay, so the range, remember, depended on which way this thing opens. Which way does this thing open? Up or down? Up, right? Okay, so our range goes from the lowest y value to positive infinity. What's the lowest y value? Negative 1/4. It's from that vertex, yeah. Negative 1/4. And technically, I guess it would be a bracket there because that's included. Gonna have it right in parentheses because we're doing ordered pairs. We also needed to note whether our vertex is a max or a min. Is it a max or a min? Minimum, yeah. So maybe over here, but min. It's a minimum. We know that about that particular vertex because it opens up just by knowing what a is, that it's a positive number. We know it does this. We know we got a minimum, and then we can find that point, and then that's going to get us our range from that y value to positive infinity. How about that? So not really crazy stuff, but it's a lot of information about one little old problem. So just and am I going to ask you for all of it about every single problem? No, I'm going to ask you for a piece of it. So hopefully you can pull that out. All right, so that's standard form. Same kind of process for any of them that are in standard form. Okay, let's look at vertex form. Sometimes you'll hear this called shifted form. Vertex form is what I'll call it most all the time. But I've had college textbooks where it called it shifted form. And it meant it like they moved it to the left, to the right, up, down, that sort of thing. All right, so vertex form, f of x is equal to a, there's that a again, x minus h squared plus k. You don't have a, b, and c here. You have a, and guess what a still tells you? Maximum, minimum, which way it opens. If a is positive, it's still going to open up. If a is negative, it's going to open down. That's the same a value. Nothing's changing about that, okay? Now, what does change, though, is all the work you got to do. There's less of it. Because if it's in vertex form, then that means the vertex must be pretty evident in there, right? So I'm just getting over all the stuff that we need here. And then intercepts. Okay, axis of symmetry and vertex are related. Here's the great thing about vertex form. The vertex is right there. It's spelled out for us. It's going to be HK. So whatever, if it's a minus in here, we'll use a positive. If it's a plus in here, we'll use a negative on the H. Remember, it's the opposite. It's kind of like the shifting that we did on the functions earlier. It's the opposite of whatever's in here. So if it's x minus 3, then the vertex is positive 3. Yeah, if it's x plus 3, the vertex will have a negative 3. And then what do we remember from standard form about the x value of the vertex and the axis of symmetry? They're the same, right? So the axis of symmetry is even right there. X equals h every single time. Yeah, it's the same value as that. So if it's a minus 3, this will be a 3. If it's a plus 3, this will be a negative 3. That's what. So you get those things just by looking at the problem. You really don't have to do any work for them. So that cuts down on some of the work. Now the intercepts, we don't get the y-intercept as easily as we did with standard form. So that we lose that nicety. But how do you get a y-intercept anyway? Yeah, f of 0. And work that out. And, so you'd have AH squared plus K is what that works out to be. Not a big deal. This is going to get us our y-intercept. To get our x-intercept, factoring quadratic formula are not an option on this because it's not in standard form. We need A, B, and C to do quadratic formula. To do factoring, we need it to be a trinomial, right? So those are not the options on this. So you would want to set the whole thing equal to 0 and solve it. Okay. And I solve by square roots. We'll see this when we go to an example. We'll go ahead and work it out. I don't think it's going to help us any to get the kind of the formula for that. It doesn't really help really much to do it. It's easier to do with numbers in there. Okay, we'll get an example in just a second. Okay, so we got our intercepts, our domain. What's our domain? Yeah, still negative infinity to positive infinity. It's still a parabola. It's still that shape. It's going, keeps going in both directions there. So it's still the same. Always. Mm-hmm. Unless we're dealing with maybe some sort of restriction like a word problem where they're say, producing some sort of product and you never can produce negative products. So, it would stop, it wouldn't go toward negative infinity and stop at 0 or something like that. Range. It's our range. What's the lowest y value? So if it opens up, the lowest y value will be where? At the vertex, right? Which is what value? K. Well, it will be a number. K is a number.
But that's what you would write.
That's the number that would be there, yes. Yeah. And it's coming from our vertex is where that's coming from. Every time, anyway. Okay. If A is greater than 0, it's going to be from K to infinity. If A is less than 0, which means it opens down, it's from negative infinity to K. Without any calculations, we get a lot of that stuff for free with the vertex form. And there are times when vertex form is the best form. There's times when standard form is the best form to have, depending on what you want. Okay, so let's look at an example of something that's in vertex form and do all this stuff for it. Okay. Example B, g of x, bless you, 2 parentheses x minus 3 squared, and then a plus 4. So again, we're going to do axis of symmetry. I'll abbreviate a little bit here. Our vertex, intercepts, and then I'm going to go down here and domain. may have to do that. So those are the things we want to be able to find for any equation, really. We know axis of symmetry and vertex are part of this because it's quadratic. And the squared part is what makes it quadratic. I don't know if I mentioned that already, but. Okay, so vertex, it's in vertex form. We recognize that form because it's got the parentheses and the squared outside and a number hanging off the end there. That's how you're going to recognize vertex form. So that's the first thing that I'm going to put in there is vertex. What's the vertex? 3, 4. Okay, and then that gives me my axis of symmetry to be x equals 3. And it does have to be that equation. If you just write 3, it's wrong. It's x equals 3. This is the equation of the axis of symmetry. So that's super quick on that. Now the not as quick part is the intercepts. Okay, so let's get our y-intercept. So we're going to plug in f or g of 0. So call this g of x. 2 parentheses 0 minus 3 squared plus 4. So we're going to get a number there. 0 something. Be 18 plus 4 would be 22. Yeah. So there's our y-intercept. Let's get our x-intercepts. And yeah, I was right. I'm going to have to move the domain. I don't want to write too small here. So we're going to set the whole thing, plus but minus, equal to 0 to find the x-intercepts. Okay. So subtract 4. And then I would divide by 2 to get the squared part by itself. It's been a while since you solved by square roots. So you take the square root of both sides. And then we know we're going to get what kind of answers here. Imaginary. So it's not going to have any x-intercepts. So this is going to be the only intercept. Let's go ahead and finish off that problem so that we know how to get the answers to one. So we finish, solving it. When I take the square root of any, I put the square root in the problem, then that means it has to be plus or minus. And that's I radical 2. And then this side is now just x minus 3. So I just got to get x by itself. Add 3. So it's x equals 3 plus or minus I radical 2. That if the I wasn't in there, it would be x-intercepts. Because the I it's got an imaginary number in there, then that means this doesn't cross the x-axis. And one of the ways that you can check that is with your graphing calculator, graph that thing. And go to and type it in just like it's written. 2 parentheses x minus 3 squared plus 4. And I'm gonna turn this plot off from what we did yesterday because I'm afraid it'll mess it up. So if you've got a plot turned on up there that's darkened in, you might want to arrow up and turn it off because sometimes it can mess up what's going on. And then I'm gonna hit graph, and I'm not gonna see the whole thing here because my graph is kind of skewed by the statistics we did yesterday. So I'm gonna hit zoom 6 to get back to a regular window. Zoom 6, and then there we see that parabola. Notice it's not crossing the x-axis. We can see that. So we can solve that and find out what's called the zeros of it, but they're not necessarily x-intercepts in this case because they're imaginary numbers. Okay. But that process of solving is the same, whether that's an imaginary number there or not. Okay. So solving by square roots is the way to do that. All right, so domain should give me negative infinity to positive infinity. The range 4 to infinity because it opens which way? Up, right? So 4 to infinity. And that 4 again comes from our vertex out of that. All right. So vertex form. It's got some nice things about it. Standard form has some nice things about it. they're all useful. Okay, I've got one more form. We'll go.
So if it up or down, would it be?
Yes. Yeah, if that A was a negative number, yes, that's exactly right. Okay. All right, so let's get the last form. And this book tends to call this Intercept Form. And so what do you think is going to be the easy part for that? The intercepts, okay? So Vertex Forms made the vertex easy. Intercept Form is going to make the intercepts easy, and it's not going to be the y-intercepts it's going to make easy. It's going to make the x-intercepts easy. Okay. In Algebra 1 and Algebra 2, a lot of times we call this the factored form. So it's going to look like a factored problem is what it ends up looking like. Okay. So you might have this function. There's that A again. It's the same A. If it's positive, what's it do to the graph? Opens up. If it's negative, opens down. That same A. Then you've got your factors or your intercept pieces. And we'll use M and N just to mean that they're numbers. So it's in factored form. Intercept form is what it's called kind of from here on out. We've always called it factored form, though, in Algebra 1, Algebra 2 kind of world. Okay? So it looks like it's been factored, right? That's what it does, okay? Now, because those intercepts are easy, the other parts are not as easy, okay? So when we go to find our axis of symmetry, it's not quite as easy. So you got some options about how to do that. I'm going to show you a shortcut. M plus N divided by 2. If you can get those two intercepts, x-intercepts, and then divide it by 2, it's the axis of symmetry. Because the reason is, like, let's pretend this pencil is the x-axis. No matter where I shift that on the x-axis, the vertex is always halfway between my two x-intercepts. And from geometry class, you did a formula called the Midpoint Formula, right? And that was just like taking half of the sum of the x's and half of the sum of the y's. Well, we're looking for the vertex there. Half of the sum of the x's would get us halfway between the x-intercepts. And that's the shortcut to getting the axis of symmetry. And then from there, the vertex, that gets you M plus N over 2 as the, make that look more like a 2, as the x value. To find the y value, you're just going to plug that in. To get that vertex. Your other option would be to like FOIL this out or multiply it out, and then you get A, B, and C and do negative B over 2A. So you would multiply these two factors together and then distribute the A to the answer, and then get negative B divided by 2A. That's another option for if it's in this form. I tend to think that's the easiest way, though, because it's quick. It's a memorized fact, but it does work every time. Okay. Let's get our intercepts. We'll talk about that. Intercepts. X-intercepts are the easiest part of this one. So x-intercepts are M0 and N0. So when you set A parentheses x minus M, x minus N, if you set it equal to 0, well, yeah, you set x minus M equal to 0 and x minus N equal to 0. That changes their sign. Yeah. So that's what it does. So if they were positive to begin with, they become negative. It just swaps the sign on them. And those are the x-intercepts. So when you look at that, again, it's in parentheses. Anytime we see things happening, 2x in the parentheses, it's the opposite of what's going on there, just like the vertex was on vertex form. Okay. So we get the x-intercepts real easy. That means the y-intercept's not quite as easy. The y-intercept, you're plugging in 0. and you end up with this product A, M, N. So it's the product of A, M, and N. I wouldn't memorize that. I've just plug in 0 for X and work it out. Don't memorize A times M times N. I don't think that's a good thing to do. Well, whatever the signs of the M and N are, yeah, you would.
You would multiply all those.
Yeah, you could to get the y-intercept, but I'm just going to plug a 0 in for X and work it out, and not even think about A times M times N, even though that's what it is. I just plug it in and work it out. Okay, let's get a problem that's in that form. Oh, we got to do domain and range. I forgot that. Ooh, that's important. We can't forget that. Domain's easy though. What's the domain? Yeah. Range. Whatever. If A is positive, and it's going to be from whatever f of m plus n over 2 is to infinity. If A is less than 1 or less than 0, it's be negative infinity to whatever that y value of our vertex is. Oh, bracket. Ah. There we go. So A is always going to tell you which way it opens, and it's always going to tell you what's going to happen with your range. Okay. All right. Let's get an example of this stuff. Example C, h of x was negative 6, parentheses, x plus 7, x minus 8. Okay. So that's in intercept form or factored form. Intercept form is what we'll try to call it. I'll probably slip up and call it factored form plenty, but intercept form is what that's called. What do we know about the graph of it just by glancing at it? Opens down, so it's doing this. Okay, so that's gonna, we know when we go to do our range, it's gonna start where? It's opening down, so it's gonna go negative infinity up to whatever that point is. So we got to find those things. Okay, so axis of symmetry, vertex. Here's what I do. Whatever form it's in, that's what I start with. So like if it's in vertex form, I start with a vertex. If it's in intercept form, I'm going to start with the intercepts. Okay, because that's going to get me M and N, right? Or my intercept values. So I'm going to get the intercepts first. So I got negative 6, x plus 7, x minus 8 is equal to 0. That's going to get me what kind of intercepts? X-intercepts. So I'm going to solve that. I'm going to divide by negative 6, get rid of it. And now I can set each of those factors equal to 0. And, once you've done several of these, you were like, oh, I can do that in my head. I know that the answers are x equals negative 7 and x equals 8. Yeah, absolutely. Absolutely. The more you can do without, having to show, that stuff, as long as you're getting them right, I'm fine with that. Okay. Y-intercept, not quite as easy. We got to plug in 0. But, you end up with 0 minus, or 0 plus 7 and 0 minus 8. And that's going to be negative 6, excuse me, times 7 times negative 8. Let's see, that'd be 42 times 8, 336. So the y-intercept is at 0, 336. I'd hate to be relying on a graph to find my y-intercept there because that's a huge graph. All right. that 6 in front really makes this a really skinny parabola. So that's why it gets, from -7 on the x-axis up to 0 on the x-axis real fast, gets up to 336. So that's fun times. All right. So from there, we can get our axis of symmetry and vertex using, the m and the n that we have, or the intercepts that we have. Okay. So our axis of symmetry, we want to add -7 plus 8 and divide by 2. Right? Positive 1/2. So x equals 1/2. 0.5. I'm not going to be too picky there. Probably in fraction form most of the time, but I'm not going to be crazy there. Now let's find the vertex. That just means plug that in. Okay. Let's see, 1/2 plus 14 is 15 over 2. 1/2 minus 8. That's 7/2. That's -15 over 2. Right. So I'm just going to multiply that out. -6 times 15 over 2 times -15 over 2. Math. Enter. 675 over 2. Fun times. 675 over 2. Again, you could type that into the y equals menu of your calculator and get it to, and go to the table and get that value if you wanted to there. So there's our vertex. We've got our intercepts. We got our axis of symmetry. We need a domain and range. Domain should be a give me. Everybody should get that right every time. If you can draw an infinity symbol. Good. Range. Remember, this one opens which way? Down. So we're starting at -infinity and going to the y value of our vertex. 675 over 2. There's a domain and range of it. So those are all our different forms that we're going to use. Now, one more example, and it's taking some information and building an equation from it. Okay? So taking some information and building an equation from it. This is example D. Write the equation of the quadratic in all 3 forms. Woohoo! It has x-intercepts at 3, 0 and -5. Or let's just call them intercepts because I'm going to give you the y-intercept too. Intercepts at 3, 0, -5, 0, and then a 0, 8. They've given us intercepts. Okay. They give us intercepts. What form do you think we need to start with? Intercept form. Okay, so that's what we're going to start with. So because we were given intercepts, we're going to start with intercept form. If they gave us the vertex, what would we start with? Vertex form. If they gave us just 3 random points, that's where the standard form would come in. You're either going to get intercepts or vertex for me. Okay, that's what I want you to be able to do. So we're going to start with intercept form. Okay, so that means intercept form, f of x is equal to a parentheses x minus m, x minus n. That's what intercept form is. So let's plug in the stuff we know. We know those two guys are M and N. And it doesn't matter which one you call M and which one you call N. Okay? X minus 3. And then the negative 5 would turn that into X plus 5 there. Okay, so we've almost got intercept form done. What do we have to find? A. Well, maybe. How could I get A? What other information did they give me that I hadn't used yet? I got a y-intercept, right? 0, 8. And 8 in for y. Because this is an X and a Y, right? So it's another point there. So we got an X and a Y value. F of X is a Y, right? It's the same thing. So I'm going to plug that in. 8 equals A, 0 minus 3, 0 plus 5. And then go from there. So that'd be negative 15. And then divide by and then reduce that if possible. It doesn't reduce. So our intercept form negative 8 over 15, X minus 3, X plus 5. Now, here's where you've got options. You can either go to the vertex form next or standard form next. I tend to like to go to standard form next, just because, I know I can multiply this out and then distribute a negative 8 over 15 fairly easily. So I'm going to go to standard form next, since I'm in intercept form. So to go to standard form, I'm going to multiply out. I'm going to start with my vertex form, and then I'm going to multiply that out. The x squared plus 2x minus 15. And then multiply out from there the 8 over 15. So once we're in standard form, that makes vertex form a little bit easier because we can find the vertex using negative b over 2a if we want to, or we could use our intercept form to find the vertex. I don't care which way you do it. Okay. That's a formula. If you're more comfortable with using that formula, negative b over 2a, and then plug it in. Here I could add, my intercepts are 3 and negative 5. I could add those together and divide by 2, and I get the x part of the vertex. Negative, or 3 plus negative 5 is negative 2, divided by 2 is negative 1. And then I could use either of these to plug in the negative 1 for, that's supposed to be an x squared right there, sorry. So if I plug that in, that'd be negative 8 over 15 plus 16 over 15, which would be 7 over 15 plus 8. 7 over 15 plus 8. Math, enter. 127.
I need all students who are benchmark testing to report to the library at this time.
Once I get the vertex, It's really easy to write it in vertex form.
Can you explain how you're?
I took the -1, I found the x value either by doing the intercepts, add them together, divide by 2, or doing negative b over 2a with this. Negative b would be
Okay, so the forms that you gave us.
before. Those
Okay.
formulas is how I'm getting that vertex.
Okay,
Okay, because if I want to write it in vertex form, I need the vertex to do that. So that's where I'm getting that.
so you can do it with either one.
Mhm. Yes, it doesn't matter which one. It's going to be the same number. It might be a good, do it with both of them and make sure you get the same number so you know you're doing it right. And then take that x value you get and plug it in,
And then get your
and
Y.
it gets the y value. That's exactly what happens. All right, and then once we've got the vertex form is easy. F of x. A is still -8 over 15. X plus 1 squared plus 127 over 15. Because it's always, that A is still the same. Okay.
You put the +1 because it was a negative. The vertex was negative.
Very good, absolutely. Because it's usually an x minus h here. So since it was a -1, I made it a +1. That's exactly right. Okay. All right. Seems like a lot. But again, you're not going, on a quiz or test, I'm not going to ask you for all of that information about any one of them. I'm going to ask you for one part of it. Like I give you one that's in vertex form and say, what are the X-intercepts? Or give you one in intercept form and we'll say, what's the X-intercepts? That sort of thing. So I'm not going to ask you for all 9 pieces of that for every problem. Okay. All right. So the suggested problems for this are on page 303, where they start numbers 11 through 87. I want you to omit 51 and 52. Those I don't want you to worry about those. So like the example D is 47, 48, 49, and 50. It shows you a graph and has points plotted on that graph. So that's what you're doing with that one. Okay. And then the rest of it, it's got questions, in the instructions of how to do that. Whatever you want to do. Odd would be what I would start with, and then if you're having, you need some more practice on ones, by all means do the even and C. Okay. All right, so you got the rest of today to work, and then tomorrow will be a work day as well. We will quiz on